Welcome back. In this video, we're going to talk about some of the serial technology that you need to be aware of with embedded systems. So again, let's just jump right into it. Now, one of the things I want to go over first is the difference between serial and parallel communications. Okay, when I started out, my first printer that worked with my first computer was a serial connection. Okay? And the way you visualize a serial connection is you have a device that's the sender, and it's sending a stream of bits, ones and zeros, to a receiver. And it's a single path. They're walking down the same path, and it's listening, okay? And it's going to collect 8 of them, and there's a byte, collect 8 more, there's a byte, and then it'll put those bytes together and build whatever information it needs to do its job. In my case, this was a printer, and printing something was very, very slow by today's standards. Okay? Parallel technology means we have a sender and the streams are going in parallel. Okay? So I can send a whole byte at a time, in some cases more than a byte, in a parallel path to the receiver. Now originally, this was a lot faster. I paid good money for my first parallel printer. And then I got a printer that had bidirectional printing. Because it was a parallel printer, it could print going this way, then the printhead could print coming back. And that was much faster. Okay? It was a much faster dot matrix printer, and it was a parallel printer. Okay? That was a big jump. Okay? Well, today, serial technology has gotten really, really fast and better than it ever was. And in some cases, it is faster to use a serial protocol than it is a parallel one. Because with parallel, you get to a certain point where you have to kind of put them back in their position, whereas in serial, you don't. They're coming in position. So there becomes more overhead with parallel than it's worth, because of the new speeds of some of the serial protocols. Okay? So we have some very low-cost serial bus technologies that work pretty darn well. All right? So let's start at the top and go through what these are. The first one was invented in 1964. And for the record, even I wasn't alive back then. Okay? But it was the RS-232. And I used these guys a lot. Okay? And they were basically to connect computers to modems, the old-fashioned AOL that you may have seen in the movies, where you'd put the phone in and it would connect to a modem, okay, and it would send the data signal through like an analog to digital converter. We'll talk about that, but basically it was a very, very slow serial process, and that was called the RS-232, okay? Then we came up with SPI. This was done by Motorola, and it's a 4-wire system. It's really the standard system for embedded systems now. SPI is, they call it a 4-wire de facto standard for serial on boards as well. Okay, so sometimes this will be traces in a burned-in board, okay, in a circuit board. And it has one master, and it can have many slaves. So one master can talk to a bunch of different devices, okay? But SPI is extremely popular. It's very low cost, and it's fast enough for what it needs to do, okay? It does a lot of onboard communications between different buses, okay? So SPI, you're going to see a lot. All right, I2C. Sometimes you'll see it I2C, probably because people don't know where the superscript thing is in Word, but it's I2C, okay? It's multi-master, multi-slave, so you can have multi-masters, it's synchronous, and it's packet switched. So the information goes into packets, not totally dissimilar to what we do with internet packets. It's information packets that are controlled over I2C. Okay, so that's another way we can do it. And I'm not sure how you say this, whether it's UNIO, UNIO, but it's UNIO, okay? and it's a low-speed asynchronous master-slave, and it only uses one signal, okay? But in its simplicity is ease of establishment, ease of maintenance, and it's a very low-cost, low-speed system, okay? So if speed's not a factor and you just need to get information from A to B on an embedded system, it's great, okay? Not a lot of complication to it at all, okay? So you're going to see that. And then they have this thing that's one wire. It's called one wire. Now in the Navy, we call the one wire our aviation electricians. They were called one wires, okay? Our hydraulics men were called bubble chasers. So I got a kick out of that when I read one wire, okay? But and ironically, it uses two wires, data and ground wires. So I guess they don't count the ground, and it's got a data wire. It's similar to I2C, but you get a lot longer range out of it. Okay, so it's, as a protocol, can go further between devices. All right. Then we have PCIe, and anybody that's bought a recent graphics card should understand the PCIe. That slot for your graphics card is a serial slot. That's how good PCI has gotten to PCIe, the enhanced version of it. Okay, it's a high-speed peripheral connection bus, and I just mentioned your graphics card. Hard drives and SSDs can go through PCIe, as well as Wi-Fi and Ethernet hardware. Okay, so it's a really good standard, and it's really fast, and it's serial. Okay, so keep that in mind. Serial is not always lesser than parallel. Okay, all right, so let's keep going. The sender sends a serial packet to the receiver. So we've got a couple more we want to talk about. RS422 is twisted pair. Okay, if you take apart an RJ45 network cable, you have 4 twisted pairs. It's good for longer runs, it's high speed, and it's to replace RS232. You don't see any RS232 ports anymore. And it's got better noise immunity, and you can get up to 10 megabits per second. Okay, and you get 1,500 meters if you're not moving at its full speed. Okay, so if you're going to go longer, it's not going to run as fast, but you can get 1,500 meters out of a cable. Okay, so twisted pair is used a lot in industrial systems. Okay, and it's the RS422 program. Now there's RS485, which is kind of another industrial one, and it's used for control systems. And it is really, really good for noisy electrical environments. Remember, I've said that you can have electrical interference on cables, right? And if that's a problem because your machines are creating a lot of electric noise, because whatever you're doing uses a lot of power on a lot of different devices, okay? And you need to go long distances with multiple things you're connecting, you're going to look at using RS485. Okay, that's the protocol that is really good for big industrial systems. Okay, all you really need to know at this point is RS485 is good for big industrial systems. RS422 is twisted pair. Okay, in the next video we're going to talk about some circuitry issues that I want you to know, because we're going to start getting close to talking about motors and actuators. Okay, so we'll talk about that on the other side.